Namaskar everyone. I am Virendra Buleria, HOD Mathematics, ITL Public School, New Delhi. Well friends, in the previous class we had done basic formulas of derivatives and we had done chain rule also. Now today we are going to discuss derivative of implicit functions. Now first of all let me tell you what are implicit functions. So functions where we have combined terms of x and y and it is difficult to write y as a function of x or x as a function of y. Such functions are said to be implicit function. Now let me explain you through example. So you can see here x square plus y square is equal to x cube into y square. Now here we cannot express y as a function of x, or sometimes it will be difficult to express y as a function of x. Now in this also you can see that here we have combined terms of x and y. So the point is implicit function, it's a function where we cannot write y is equal to fx easily. Now let me tell you how to take the derivative of such functions. So let us start with some examples. So first example you can see x square plus y square is equal to a square. Now you will start by saying differentiating both the side with respect to x. So let's start. Differentiate both sides with respect to x. So when you differentiate this with respect to x, your output will be 2x plus 2y dy upon dx is equal to 0. Now derivative of x square is simply 2x, derivative of y square is 2y, then we have to take the derivative of y also. So that is why we are getting dy upon dx. Now a square is a constant quantity, so that is why its derivative is simply 0. So after this it's a matter of calculation. Just you will write dy upon dx is equal to this expression. So finally you will get minus x upon y as the answer. So this is one example. Now let me consider one more example. So here again we have combined terms of x and y. Now how to take the derivative of this function? So again you will write differentiating both the side with respect to x. So let us start this. Differentiate both sides with respect to x. Now here this is x into y. So we need to apply product rule of two functions. This is first function and this is second function. So when you take the derivative using product rule, this is what you will get. 1 into y plus x into dy upon dx plus 2y dy upon dx is equal to, now the derivative of sine y will be cos y, then we have to write dy upon dx. It is again because of chain rule, because you have taken the derivative of sine y. After that we have to take the derivative of y also. So that is why we are getting dy upon dx. Now after this you will just club all the terms of dy upon dx on one side and remaining terms on other side. So this is how you will do that. Minus cos y is equals to minus y. So finally you will get dy upon dx is equal to minus y upon x plus 2y minus cos y. So this will be our final answer. Okay, now let me give you some other example. So you can write down this one. This is another example. Now here we can see that this is x upon y. So when you take derivative on both the side, you have to apply quotient rule. So differentiate both sides with respect to x. So when you differentiate, this will be 1 into y minus x dy upon dx divided by y square, and on this side it will be sec square y then dy upon dx plus 2x. So let me explain you this once again. On this left hand side, we are applying quotient rule. So as per quotient rule, derivative of numerator will be 1, denominator as it is, minus numerator as it is, derivative of the denominator will be dy upon dx, divided by denominator ka square, is equal to, so tan derivative is x square y, then we have to take the derivative of y, so that is why we are getting dy upon dx, and derivative of x square is simply 2x. Now after this it's a matter of again calculation, so just cross multiply this y square on this side and club all the terms of dy upon dx on one side. So this is how you will proceed. Y square into sec square y dy upon dx plus 2xy square. So just take dy upon dx on one side. So when you do that, it will be dy upon dx minus x minus y square sec square y is equal to 2xy square minus y. So shift this term over here and that will give you the final answer. So finally I can write this as dy upon dx will be y minus 2xy square divided by x plus y square into sec square y. So what I had done, I had first taken this minus sign on this side. So that is why it will become y minus 2xy square. And then I had dropped this term on this side. So this is how we can get the derivative of this particular function. Now let me give you another example. Now this particular question is very important. In board exam, this question has come for 4 marks. So x square plus y square the whole square is equal to xy. Now just see, this is the expression. So we want to differentiate. The question is find dy upon dx. So the question is find dy upon dx. Now how to proceed? So we have two methods. Either you can apply chain rule here, or if you want, you can expand it and then you can take the derivative, right? So let me expand this and then I will take the derivative. So x power 4 y power 4 plus 2x square y square is equal to xy. First I had done this a little bit of algebra. After that, I will differentiate both the sides with respect to x. So differentiate both sides with respect to x. So when you do that, its impact will be 4x की power 3 plus 4y का cube dy upon dx plus 2 will move outside. Now when you take the derivative of x square into y square, you need to apply product rule. So let us apply product rule over here. So when you apply product rule, this is what you will get. So this is by the application of product rule. So let me explain you once again. I had taken this 2 outside, derivative of x square is simply 2x, y I had written as it is. After that, I had taken the derivative of y square, so it will be 2y dy upon dx, and I had written this x square as it is. Now on this side, you need to apply product rule. So when you apply product rule, your output will be 1 into y plus x into dy upon dx. So this is what you will get. Now, after this, again, you have to just take this dy upon dx on one side and remaining terms on other side and you will get the final answer. So that you can do yourself, that is not a problem. So just quickly write down this question. Okay, so after this, let me give you one more example. Now this question again has come in board exam for 4 marks. So let me discuss that question completely. So question number 5, here we are saying tan inverse y by x is equal to log x square plus y square. Question is find dy upon dx. So we want to take the derivative of this expression. Now here again, we will write differentiating both the sides with respect to x. with respect to x. Okay, so when you differentiate, now when you differentiate, you will apply that formula for tan inverse x. So the formula for tan inverse x was 1 upon 1 plus x square. Now y by x is playing the role of x, so that is why I had written it. After that, using chain rule, you have to take the derivative of y by x also. Fine. Now, on this side, it will be 1 upon x square plus y square, because you know that the derivative of log x was 1 by x. After that, we need to take the derivative of x square plus y square. So, this is again by the application of chain rule. Now, let us proceed further. So, here I can take LCM and I can rewrite this expression as this. So, when you apply that quotient rule here, it will be x square. Now, derivative of numerator, that is dy upon dx, denominator as it is, minus derivative of denominator, numerator as it is. This is quotient. And on this side, you will get this as x square plus y square, 2x plus 2y dy upon dx. Okay, now friends, it's time to do little bit of calculations. So we can see that this x square and x square will cancel out. X square plus y square, x square plus y square cancel out. Now you will take all the terms of dy upon dx on one side. So when you do that, this is what you will get, is equals to 2x plus y. Now you will just write dy upon dx will be equal to 2x plus y divided by x minus y. So this will be your final answer. So let me recall this again. This was the question, find dy upon dx. Now we had written differentiating both the sides with respect to x. So tan inverse x, the derivative was 1 upon 1 plus x square, that I had written. After that, I need to take the derivative of y by x. Over here, 1 upon x square plus y square. Then we need to take the derivative of x square plus y square. Now, here I had applied quotient rule, and the derivative of this will be 2x plus 2y dy upon dx. Now after that, x square and x square will cancel out. Here I had just taken LCM, and if you see this carefully, then x square plus y square, x square plus y square will also cancel out. So we left with this bracket and this bracket. Now after this, just it's a matter of taking dy upon dx on one side and terms free from dy upon dx on one side. After that, dy upon dx can be written as 2x plus y upon x minus 2y. So this is our final solution. Now let me give you some questions based on this derivative of implicit functions, which you can do as homework. So homework for the day, you can write question number 1. So we want to find dy upon dx for all. So first question is x square plus y square is equal to x to the power 3 y to the power 3. Number 2, sin y plus cos square x is equal to pi. Number 3, tan square x plus y ka square is equal to y upon x. Number 4, cot inverse y upon x is equal to log x square plus y square. Number 5, x ka square y ka square to the power of 3 is equal to x plus y plus 1. Number 6, x square upon a square plus y square upon b square is equals to 1. So as a homework, you can do these 6 questions. So that's it for today.